Math is Lee. Math's easy when you're doing math with Miss Lee.
Hello, in this video I will be finding the key features of the rational function y equals 3x minus 6 and graphing it without a calculator. So my first step is to factor the numerator and denominator. So the numerator has a common factor of 3 and the denominator has a common factor of x. I'll use this to find the restrictions and then the domain. So I can see from the denominator, the factor of x tells me that x equals 0 is a restriction, and x minus 2 tells me that x can't equal 2. So my domain is all real numbers except 0 and 2. In interval notation, that would mean I have a section that goes from negative infinity to 0, 0 to 2, and then 2 to infinity. So when I make my graph, it's going to have to represent sections for all of those x values. Next step is to reduce. I can divide the numerator and denominator by their common factor of x minus 2. So my reduced function is y equals 3 divided by x. So I can see that after I reduced, x equals 0 makes the original fraction and the reduced fraction undefined. So that's the equation of my vertical asymptote. X equals 2 makes the original fraction undefined, but I can actually plug it into the reduced fraction and get a y value back. So there is a hole at x equals 2. But here I'm actually going to find both coordinates. So 2 comma something. And the way that we find the y coordinate is we plug 2 in for x in our reduced function. So my reduced function is y equals 3 over x. Plugging in 2 for x, I get y equals 3 halves. So when I plug in 2, I get 3 halves, and that's going to be graphed as an open circle in my graph later on. For the horizontal asymptote, I compare the degree of the numerator and denominator, and I'll use the reduced fraction for this. So 3 over x, the 3 has a degree 0 because there's no x in it, and the x has degree 1 because that's x to the first. So there's a greater degree in the denominator. If I think back to my rules, that means that y equals 0 is a horizontal asymptote here. Next step is to find the intercepts. Again, I'm going to use the reduced function. So I really only use the original function to help me find the domain and the restrictions. So finding intercepts always involves plugging in 0 for the letter you're not finding. So if I want the x-intercept, I'm going to fill 0 in for the y. So I'll have 0 equals 3 over x. There's nothing that I can divide 3 by to get 0 as an answer. So that means that there are no x-intercepts for this graph. And then same thing, if I want to find the y-intercept, I'm going to fill 0 in for the x and solve for y. And that gives me y equals undefined, so there are also no y-intercepts. So now I'm going to graph all the information that I found. I found that we have vertical and horizontal asymptotes at x equals 0 and y equals 0. So that's going to appear as a dashed line. Y equals 0 is the x-axis. So I'm just making it a little bit above the x-axis so I can still see that it's there. And then same with my vertical asymptote at x equals 0. That is the y-axis. So I'm just going to make it a little bit off of the axis so I can see it. And then I'm supposed to have a hole in the graph at 2 comma 3 halves. So that's approximately here. And notice I graphed that as an open circle. So now we have to fill in the rest of the graph. I don't have any x or y intercepts, but if I did, I would have graphed those as closed circles on the x or y axis as appropriate. The rest of this may feel a little like faking to you, but I do know that what's supposed to happen on both sides of a vertical asymptote is that the graph is supposed to go up or down infinitely on either side. So if I use my open circle here as kind of an invisible point on the graph, I know the graph will have to extend upwards infinitely from the left side of that vertical line If I made the graph go down infinitely from the open circle, then I'd be making an x-intercept, and I know I don't have x-intercepts. The graph is also supposed to approach my horizontal asymptote as I go out to the right, so I'm just going to make it look like it does that. And again, if you're not comfortable with doing that, you could certainly plug in 1 for x, 3 for x to get other points on the graph, and then graph it a little more precisely. But this is only a sketch. So if we go back to our domain, x is still allowed to be a number less than 0, so I need to be able to show that in my graph. If I stop here, then it looks like x isn't allowed to be a negative number. So this is where I will plug in a number for x. So I'm just going to choose -1 for x, and when I plug it into my reduced equation y equals 3 over x, y comes out to be -3. So the point -1, -3 is a point on the graph, so that gives me a point in that missing section. Again, the graph should go up or down infinitely along the vertical line. I know it has to go down because if I made it go up, I would be creating an x-intercept that's not supposed to be there, and then it's supposed to follow the horizontal line out to the side. And again, if you don't like faking that part, you can plug in -2, -3, get other y values, but this is only a sketch. So I'm expecting at least 1 point in each section to be accurate. The holes, the vertical and horizontal asymptotes, and the intercepts, those have to be graphed accurately. Everything else can be a sketch. So I'm looking for the arrows to be pointing in the right directions along those asymptotes.